In this video we are going to assemble the quadcopter. So first we will start connecting ESCs to the motors. So for the 4 motors we are having 4 ESCs. We already know how to work with these ESCs. So coming to the quadcopter configurations, we are having plus, cross and H. So we are going to focus on H configuration. So here we are having the H frame. So this is the front direction and this is the back. So we have to connect ESCs to the motors. So here we are having 3-phase BLDC motors. This is how you can connect the motors with the ESCs. So here you can see for H configuration, this is the first motor which is rotating, it should rotate in clockwise direction, and second should also rotate in clockwise. Third and fourth motor should rotate in anti-clockwise direction so that the flight or frame will be stable in the air. So now I am going to connect the second motor. So there is no polarity between the ESC and the motor. You can connect in any direction, but the thing is, to change the direction of the motor we have to change the connections. So after connecting the ESCs, we are going to calibrate these 4 motors with these ESCs. So calibrating is nothing but telling the motors minimum and maximum positions of the speed. So now these 4 ESCs are attached on the back side using the cable ties. So these are the cable ties. By using these cable ties we are going to attach these ESCs permanently to the frame. So we have connected the 4 ESCs to the frame. Now it's time for calibrating the each motor individually or manually. So first, what is meant by calibration? Calibration in sense telling the maximum and minimum speed for the motor. So by using this throttle stick we are going to tell minimum and maximum speed. So for that purpose we have to connect ESC to the channel 3, which is throttle. So here I am going to connect my third motor to channel 3. Next I am going to give the power supply for the third ESC. So before that, to calibrate the ESC, you should make the throttle at maximum position and turn on the transmitter. After that, connect the battery. After connecting the battery, you will hear 2 beeps. After hearing the 2 beeps, simply put the throttle stick at the minimum position and you will hear again 3 beeps indicating that 3S LiPo, and finally you will hear a long beep, that means the motors has been calibrated. So I am making the throttle stick at maximum and connecting the LiPo battery. So after 2 beeps, so just now we had 3 beeps along with the long beep. So 3 beep in sense, here we are using 3s LiPo. If you are using 2s LiPo, you will hear only 2 beeps. Just increase the throttle a little bit, so the motor will start rotating. So here, just now I have set the minimum and maximum speed for the motor. So for H configuration, this motor should rotate in counterclockwise direction. So we have to check this motor is rotating in counterclockwise direction or not. So here you can see this motor is rotating in counterclockwise direction. If it is not rotating in counterclockwise direction, simply interchange any 2 wires so that it will rotate in other direction. Similarly, we are going to calibrate the second ESC, that means this one. So for that purpose, the same procedure, the throttle should be high and transmitter should turn on. This BAC is connected to the third channel. And connect the battery. After 2 beeps, so we got 3 beeps along with the long beep. So just increase the throttle. You can see. So now we will check the direction of this motor. This motor is rotating in counterclockwise direction, but for the H configuration, the first motor should rotate in clockwise direction. For that purpose, we have to change the connections. So here I am going to interchange the connections. Interchange any 2 wires. Now check the output. Now it is rotating in clockwise direction. Similarly, we have to do for the other 2 motors. So this is the manual calibration, means we are calibrating 1 by 1 ESC. There is one more calibration method, that is we have to calibrate these 4 motors at a time by using the flight controller, so that the 4 motors will start at the same time and they will stop at the same time. Because to gain stability, the 4 motors should stop simultaneously so that it will get stability, or otherwise it may get some tilts. So now we will do the calibrations for other 2 motors also. So remove the battery. So throttle should be maximum and it should be connected to third channel, that is throttle, and connect the battery. So this is the second motor. This should rotate in clockwise direction. We will check whether it is rotating in clockwise or not. So it is rotating in anti-clockwise direction. So we have to change the connections of the motor with the ESC. Now it is rotating in clockwise direction. And the same thing for the last motor. This motor is rotating in anti-clockwise direction. So just now we have set the motor directions for the H configurations. 2 should rotate in clockwise and 2 should rotate in anti-clockwise direction. So this is how we can calibrate the ESCs manually. Now we are going to connect these 4 ESCs to the APM board. So before that we have to give power supply for these 4 ESCs. So for each ESC there is individual power cable. So to combine these 4 cables we are going to use this one. So these 4 female connectors are connected in parallelly, and finally we got one pin. So to this pin we have to connect the battery like this. So after that we have to connect to the 4 ESCs so that the 4 ESCs will get power from this battery. So this is the T connector, this is the minus and this one is the plus. So make sure that you should follow the correct polarity. So black one is minus, so minus is connected to the minus and plus is connected to the plus. Similarly for other 3 connectors. So there should be no short circuit. So if short circuit happens after connecting the battery, it may damage. So now we have connected the power supply cable. Next we will connect the signal wires, that is ESCs, to the APM board. So this one is the first motor. First is connected to the first output pin. So white one is the signal, this one is the black one is VCC ground and red one is VCC, and this is the second motor. So second is connected to the second, and this one is the third. If you are making X configuration or plus configuration, the pin numbers may change. So this one is the fourth is connected to the fourth. Now place the APM board at level. So first I will place here. Now we will calibrate these 4 ESCs or 4 motors at a time by using APM. So for that purpose, make the throttle at maximum position, turn on the transmitter and connect the battery. So after connecting the battery, observe the LEDs here. So all LEDs will turn on one by one. That means the APM board is under calibration mode. Here you can see LEDs are looking like running, that is LEDs are going one by one, red, yellow and blue, means it is under calibration mode. At this time remove the power and reconnect it again. So after 2 beeps, reduce the throttle stick. You will get 3 beeps indicating 3S LiPo, and finally you will head here one long beep. So now increase the throttle. After increasing the throttle, the 4 motors should start at the same time, indicating that motors has been calibrated, that is ESCs has been calibrated successfully. So now I am increasing the throttle. Here you can see 4 motors are starting at the same time. So ESCs are calibrated successfully. So at the same time you have to check the direction of the motors. These 2 motors should rotate in clockwise and these 2 should rotate in anti-clockwise for H configuration. So this is rotating in clockwise and these 2 are rotating in anti-clockwise direction. So this is how you have to calibrate the. Now we will see the output of motors by varying the quadcopter frame. So initially it will move into the air like this. So whenever it bend towards left, the speed of these 2 motors should increase so that it will be in the level position. Similarly, if it bend right side, these 2 motors should rotate at high speed compared to these 2 motors so that it will stabilize. Similarly for forward and backward. So by varying this orientation of the frame, the speed of the motors should change. So if they are not changing, you will not get stability in the air. So now we are going to check whether it is getting stability or not by connecting the battery. So first turn on your transmitter. Put the throttle stick at minimum position and connect the battery. Put the quadcopter in level. So on the APM or quadcopter. So here you can see the indication that the bolt has armed. Now I am going to give some throttle and the motors will start rotating. Now I will change the orientation of the frame and we will see the output of the motors. So initially 4 motors are rotating at same speed. Now I am going to vary the orientation. Here you can see these 2 motors are rotating at high speed when compared to these 2 motors. Similarly, when I bend like this, these 2 are rotating at high speed. Similarly, forward and backward. Here you can see the variation of sound. Means the motors are responding to the APM board orientation.